Alrighty, this is our pre-calculus quarter 1 technology project, mathematical modeling. We were group 7, we had problem 7. So the problem was, we have a track with semicircles on the ends. The track has a perimeter of 1,000 feet. Part A, we need to find an equation to model the area A in terms of the diameter of the semicircular ends, x. B, we need to find the maximum area, and C, we need to find what radius of the track will make the track area greater than 60,000 feet. So for starters, the dependent variable is the area inside the track, A, and the independent is the diameter of the track, x. So here's the picture. This whole track has a perimeter of 1,000 feet. Sorry for that annoying little thing in the bottom. The rectangular section has a length y and a width x, and then the semicircular ends just have this width. This diameter x. The first thing you need to know, the circumference formula is pi times the diameter, which in this case is x. And so to find our final formula, we already know what the perimeter is. The perimeter is 1,000 feet. So 1,000 feet has to equal the circumference formula, pi times the diameter x, plus 2y, 1y, 2y for the rectangular. So now, and because these are semicircles, and there's 2 of them, we can just use the formula for the whole circle. So these 2 are modeled by pi x, and these are modeled by 2y. The next step is to find the area of the whole thing. Now this can be broken up into 2 shapes, a circle, these 2 combined, and a rectangle. Now to find an area of a rectangle, you do the length times the width, which in this case are y and x. And to find the area of a circle, it is 1/2 the diameter, x squared, times pi. So the total area is the area of the rectangle, xy, plus the area of the circle, pi x over 2 squared. So now we need to model the area in terms of the diameter x. But the previous equation we found has a y in it. So we need to use the equation we found in step 1 to find y in terms of x. So what that means is we just need to get y on its own. So we subtract pi x from both sides and then divide both sides by 2. Easy. Now we've got 500 minus pi x over 2 equals y. We found a version of y that uses x that we can now plug into the area equation. The old area equation, a equals xy plus pi of x over 2 up to the second, has a y. We can't have that. We need to express the area in terms of x. But we just found a way to express y in terms of x. So we found the equation, we plugged the equation found in step 3 in for y, for the y in this equation to get x times, in parentheses, right, because we need to plug in the whole equation, 500 minus pi x over 2, end parentheses, plus pi of x over 2 squared. Now we can express a in terms of x. All this really means that we write out a of x equals rather than just a equals. So our final equation, a equals x times 500 minus pi of x over 2 plus pi times x over 2 squared. We just need to simplify this and put this in terms of x. So a of x equals, and then we multiply the x to both terms, 500x minus pi x squared divided by 2, plus pi times x over 2 squared. Now, we can take care of the squared to get the previous equation, plus pi x squared, pi times x squared over 4. Now, both of these x squareds, we need to add them together in order to fully simplify. However, currently, this has a base of 2, and this has a base of 4. This can easily be solved by multiplying this term by 2 over 2 to get us a final equation. A of x equals 500x minus 2 pi x squared divided by 4 plus pi x squared divided by 4. We can add everything together, rearrange a couple terms, just move this out to the front to get negative pi x squared over 4 plus 500x. Now we have our final equation, which enters part A of the question. Now it's time to apply it.
Alrighty, so now we have to apply our equation and find the maximum area of the track. So first we go to y equals, we type in our equation, negative pi x squared over 4 plus 500x. Next, before we hit graph, we have to go to our window. And then for our X windows, we set it to -15 to 700. And our Y's, -15 to 80,000. And we hit graph. We see this beautiful graph here. And then we hit second calc. And we go to 4, maximum. And we go back to the graph. And we go to the left side, hit enter. Go to the right side, and we hit enter again. And it will give us our maximum area of 79,577.5 feet squared.
Okay. So first, we plugged in our original equation to y1 and plugged in 60,000 for y2. Created the parabola and the intersecting line. Then we found where they intersected with each other for the first time. And we hit enter twice, and then we figured out that the first intersection point was 160.4 was the minimum. So to get the radius, we need to divide it by half to get 80.2 feet as our minimum. And then we did the same again for the farthest intersection point. And we hit enter twice, find 476.2. But since we need the radius, again, we half it to get 238.1 as our max. So the range of values where the area will be greater than or equal to 60,000 is 80.2 to 238.1.
Alrighty, these are our final answers. We hope you guys have enjoyed this project, and we hope you've learned a little something from it.